Good morning, everybody. And in this talk, I will present you a research project that I, with Valeria Zalini and Simone Zaggia, are carrying out in order to study and analyze both the scientific and technological value of the meridian circle, one of the most important instruments used by the Paduan astronomer, and the astrometric science that this instrument has been produced. This work was presented in a preliminary version in the 36th SISFA Congress, and now we present it in a more complete version. So, the astrometric science in the last year has been revolutionized by the new space mission like Hipparcos and GAIA. And in particular, GAIA, with its last release, make it possible to know the position of 1.8 billion of stars up to 20 magnitude with a very, very high precision, more or less from 0.01 millisecond to 1-2 millisecond. And in addition, in the DR3, in the last release of GAIA, we have also the information about proper motion, parallax, color index for about 1.5 billion stars. So GAIA have a big problem because the brightest stars are completely saturated in the GAIA detector. And so to resolve, in order to overcome this problem, there are different approaches. One of these can be the use historical catalog with a long time timeline baseline, more than 100 here. And this catalog, historical catalog, could help to improve the astrometric data. And in particular, in this background, the Paduan catalogues realized by Giovanni Santini in the middle of 19th century can play a very important role because thanks to this, we can study both the position of the brightest star, but also we can analyze the proper motion of the star in order to find particular element, particular evolution of this parameter. So, what is the Paduan catalog? Giovanni Santini decided to realize this catalog because he didn't have a stellar catalog with a lot of reference stars in order to calculate the orbit of comets and asteroids. And so in 1837, Santini decided to realize this catalog with the help of Virgilio Trettanero. And in particular, in this plot, you can see the position of all stars that are collected in this catalog. This is 5 catalogs, and in particular, the different colors show in the purple and in the blue the star observed directly by Santini in the first and in the second catalog. Instead, in the other color, you can see the position of the star observed by Trettanero in the third, in the first, and in the 5th catalog. In general, in this 5 catalog, we can find the position, the magnitude, and the correction for the annual precession for about 10,000 for 10,530 star up to 10th magnitude with a declination to minus 50 degree to 20 degree. And to realize this catalog, Santini used the meridian circle. Meridian circle is a very innovative instrument realized for the first time by Georg Friedrich von Reichenbach in 1810. This is a very innovative instrument because before the introduction of this system, the astronomer, in order to obtain the position of the star used two different instruments, the quadrant mural and the transit instrument. Instead, Reichenbach fused these two instruments into one, the meridian circle. The first two meridian circles are used by Gauss and Bessel. Instead, the meridian circle that you can see in this picture arrived in Padua in 1836, and it was realized by Christoph Stark, the mechanic of the Royal Polytechnic Institute of Vienna. And when this instrument arrived in the observatory, director Santini put this instrument in this dome here, and immediately he started to test this instrument in order to understand all the characteristics of this. And in 1837, he started to use this instrument in order to realize his catalog. At the beginning of the catalog, Santini described in detail all the procedure that he used to obtain his data. And in particular, the observation started immediately after the sunset, and the astronomer observed the sky for a couple of hours every night in order to obtain the position of about 20 stars for each night. All the data are collected in the Meridian Register, and this is a picture of one of the pages of the Meridian Register. And here, the astronomer collected the observation. Here, then they corrected the position for, in this case, for example, you can see the right ascension and declination for a star with a magnitude 8-9 magnitude. And this is the position that he obtained by the instrument, the correction for the clock, and finally the right ascension. Instead here, the declination, the observation, the various correction, and finally the declination of the object. And Santini observed this is every star for in 3 different nights in order to reduce error. And so Tretanero in the 3rd, 4th, and 5th catalog observe each stars instead only 2 times. And then the astronomers write the average of this position finally in the catalog. So in the first part of our analysis, in the first part of our work, we analyze the position, the characteristics of the Padua catalog, and it's particular in this plot you can see the position of the star observed directly by Santini, and Santini between 1837 and 1846 observed more or less more than 4,000 of stars with an average magnitude of 7.5. Instead, in this other plot, you can see the position of the star observed by Tretanero, and he observed more than 6,000 of stars with an average magnitude of 8.3. This histogram shows the distribution of the magnitude of the stars. In particular, we don't have the data because Tretanero died before to finish his work. So, after this, we match all the stars observed by Santini and Tretanero with the star with the GAIA data. In particular, we use the early DR3 that from an astrometric point of view is equal to the last GAIA release. And in order to do this, we correct the position of the GAIA for the precession and proper motion. And to do this, we use AstroPy, a particular library written in Python language for the astronomical and with many astronomical elements. And this plot shows the position of the star that have a match with the star of GAIA. The blue dot with the red circle represent the stars with a match. Instead, there is some green star here that are the stars observed by Santini that don't have a match in Gaia. More or less, both in the Santini observation and in the Trettenero observation, there are more or less 10% of stars that don't have a match in Gaia. And at the end of this, we analyze the residual of the position of observed by Santini and Trettenero. In particular, here you can see the distribution of the residuals of the star observed by Santini, and we can see that there is an offset in the residuals of the declination and both in the right Shensen. And this, you can see the trend of the residuals versus right Shensen and the declination. So why there is this offset and this particular trend where you can see the residuals that go up, go down, and so on. We have two hypotheses. The first one, we think that there is some seasonal effects. In fact, we realize the same plot where you can see the position, the residuals versus the coordinates in the different seasons. And here we see that the change of the shape is where the change of seasons, winter, spring, and so on. But we think that is not the correct idea, because we analyze another catalog, the BICE catalog, and we see the same shape observed in the Santini data, and so we don't think that this the seasonal effect is a correct idea. There is another hypothesis under the study that, and this depends on the use of different reference systems. In fact, GAIA use a reference system, ECRS reference system. Instead, Santini don't use any reference system, a fundamental catalog, and so on. And now we are studying if there are some error in the position of the Bessel star, because Santini used the Bessel star in order to test the instrument in order to correct the position of the star. Anyway, we corrected the position of the residual for the various, this offset, this 0 point, and we apply statistical analysis in order to obtain the final error of this on the position of Santini. And we find that in this case, we have an error of about 1.6 arc second. That means under a baseline of 1070 years, an error of more or less 10 milliarc seconds. We applied a similar analysis in the data, in the Trettenero data, and here the distribution of the residuals. And in this case, we see that the offset is lower than the previous data, because in this case, the astronomer made some upgrade to the instrument. For example, they use a new micrometer, a new element. And also in this case, we applied a similar analysis, and we find a final error of 1.7 arc second. So after this analysis, we study the proper motion. In particular, we use the proper motion of Gaia, and we calculate directly the proper motion using both the Gaia data and the position of the star observed by Santini and the position of star data. And here we can see the residuals of the proper motion in the Santini data and in the Trettenero data. And we see that there is a very good accord between the two, the Gaia and Santini, and in particular using this data. So we have an error of 20 milliarc seconds. So under this error, we don't say nothing. But for these stars that have high residuals over 2.5 sigma, we can use we see, we could use this data in order to analyze, to improve the GAIA data. So finally, we applied a similar analysis to the VICE catalog. VICE is a Polish astronomer that take the vessel data and process all this data to similar data of 1825. And in his catalog, there are 31,000 stars. We analyze the magnitude, the position, and also we obtain a similar analysis. And in this case, the error of on the VICE vessel data is about 2.6 arcs. And so finally, here you can see how the Santini data in blue and the VICE data in the same part of the sky observed are a similar shape, and in the Santini data, the distribution is there is a lower residual than VICE. So, in order to conclude, we can say that the data observed by Santini is a very, very good data with a very high precision for the time. In particular, in this plot, you can see the position, the error versus the here, and the Santini is here. This means that the Santini is the best stellar catalog for the time. In particular, we use this data in order this data can help to improve the modern astrometric information. In particular, the next step is to use other stellar catalog, for example, Bessel, Piazzi, Santini, and GAIA, in order to analyze the proper motion of the star and realize a model in order to study the evolution of the proper motion and test this with the data observed by GAIA and other astrometric missions. So, thank you very much, and if you have some questions, please.
Thank you very much. Other questions, comments? Yeah, but I actually have to. Can you see correctly the possible utility? So we use this data to understand, to look for, to use the tempo, the proper motion, right? This is what you're going to do, but this is not yet done. I mean, how does this work of using historical data received by the community of astronomers working on current data taking?
So this work starts in order because the carbon catalog are considered a very high important astrometric, very high precision astrometric catalog, and so we start in order to understand if this is true or not. And after this analysis, we have to understand that this data can help to improve astrometric data, for example, the proper motion. So, I'm sorry. In this case, for example, so in this case, we have some star with a high residual in the proper motion more than 2.5 sigma. And so, why this? There is some problem in the observation by astrometric mission, for example, GAIA, and so we analyze the proper motion. So we have the data observed by Santini 170 years before. We have the data from Bessel, we have the data from Piazzi, and in this way we can realize a model to understand the proper motion, and so we can understand if the data obtained by GAIA can understand. Yeah, obviously GAIA is more precise than Santini, but in this we can probably give a little help to improve the astrometric data, in particular in the brightest star, because the GAIA is a very big problem for the brightest stars in particular.
This is your, I mean, so far perception, you are not cooperating with GAIA to improve GAIA.
Not directly.
Not directly, so it's still to be well received by the astronomy community, right?
Yeah.
Still question to the next year. What do these people mean by star position because of star variation? Is the center of the ellipse?
Santini corrected the aberration of the star, the position, using a table from other astronomers, in particular from Carlini, astronomer in Milan. So in the observation of the Santini, we have a correction for the aberration. So this is one element that we have to study in order to understand the real correction of the data.
Thanks. Are there any questions or comments? Okay, we can.